Ever wondered why your code runs perfectly on a small dataset but crawls when it scales? Understanding complexity analysis is the difference between a junior developer and a senior engineer. In this video, we will cover DSA complexity analysis practice questions and Big O notation explained. Master data structures and algorithms by perfecting your complexity analysis skills. In this video, we dive deep into 30 essential practice questions for DSA complexity analysis. We will cover Big O, Big Omega, Big Theta, and how to evaluate both time and space efficiency for various algorithms. Before we begin, make sure to grab a pen and paper. Pause the video for each question and see if you can solve it before I reveal the explanation. Which notation provides a strict upper bound on the running time of an algorithm? Option A, Big Omega, Omega. Option B, Big Theta, Theta. Option C, Big O, O. Option D, Little Omega, Omega. The correct answer is C. Big O notation. O is used to describe the upper bound of an algorithm's running time. Representing the worst-case scenario, it ensures that the algorithm will not take longer than a certain amount of time. In contrast, Big Omega provides a lower bound, and Big Theta provides a tight bound, both upper and lower. Big O is the most commonly used notation in industry to define efficiency because it guarantees that the execution time will stay within a specific limit as input size grows. What is the time complexity of a loop that starts at 1 and doubles the counter variable in each iteration until it reaches n? Option A, oxygen mononitride. Option B, O, log n. Option C, O, n log n. Option D, O, 1. The correct answer is B. When a loop variable grows exponentially, e.g., I equals I asterisk 2, the number of iterations required to reach n is logarithmic. Specifically, if we start at 1 and double until n, we are solving for k in the equation 2 caret k equals n. Taking the log of both sides gives us k equals log 2 n. Therefore, the time complexity is O log n. This is typical for algorithms like binary search or finding the height of a balanced binary tree. An algorithm uses a fixed amount of memory regardless of the input size. What is its space complexity? Option A, oxygen mononitride. Option B, O, log n. Option C, O, n squared. Option D, O, 1. The correct answer is D. If the memory used by an algorithm does not scale with the size of the input, n, it is said to have constant space complexity, denoted as O. 1. This usually applies to algorithms that only use a few auxiliary variables for calculations and do not allocate extra arrays or data structures that depend on the input size. Even if the input is a billion elements, O. 1. Space remains the same. What is the time complexity of two nested loops where the outer loop runs n times and the inner loop runs n times? Option A, O, 2n. Option B, O, n log n. Option C, O, n squared. Option D, O, n cubed. The correct answer is C. In nested loops, the total number of operations is the product of the iterations of the loops. If the outer loop runs n times and for every single iteration of the outer loop, the inner loop also runs n times, the total work done is n asterisk n equals n squared. This is characteristic of algorithms like bubble sort, selection sort, and insertion sort in their worst cases. As n increases, the time taken grows quadratically. Using the Master Theorem, what is the complexity of t, n, equals 2t, n, 2, plus n? Option A, O, n. Option B, O, n log n. Option C, O, n squared. Option D, O, log n. The correct answer is B. According to the Master Theorem for t, n equals at n b plus f n. Here a equals 2, b equals 2, and f n equals n. We compare f n with n caret log underscore ba. Here n caret log underscore 2 equals n caret 1 equals n. Since f n is equal to n caret log underscore ba, we fall into case 2 of the Master Theorem. This results in a complexity of O n caret log underscore ba asterisk log n, which simplifies to O n log n. This recurrence relation describes the behavior of the merge sort algorithm. Which of the following growth rates is the slowest? Option A, O, n log n. Option B, oxygen mononitride. Option C, O, log n. Option D, O, n squared. The correct answer is C. When comparing growth rates for large values of n, the hierarchy is O, 1, less than O, log n, less than O, n, less than O, n log n, less than O, n squared, less than O, 2 caret n. Logarithmic growth, log n, is extremely efficient. For example, if n is 1 million, log 2, n, is only about 20. This makes logarithmic algorithms much faster than linear n are quadratic n squared algorithms as the input size increases. What is the space complexity of a recursive function that calculates the factorial of n? Option A, O, 1. Option B, oxygen mononitride. Option C, O, log n. Option D, O, n squared. The correct answer is B. Even though the recursive factorial function doesn't explicitly create an array, it uses the call stack. Each recursive call adds a new frame to the stack containing the function's parameters and local variables. Since there are n recursive calls, n n1 1, before reaching the base case, the stack depth is n. Therefore, the space complexity is O, n. If implemented iteratively, the space complexity could be reduced to O, 1. What is the amortized time complexity of an append operation on a dynamic array, like Python's list or Java's ArrayList? Option A, oxygen mononitride. Option B, O, log n. Option C, O, 1. Option D, O, n squared. The correct answer is C. While a single append might take O, n time if the array needs to be resized and copied to a new location. This happens very infrequently. Specifically, when the capacity is reached, most appends take O, 1. When you average the total time for a sequence of n appends, the total work is O, n. Dividing by n gives an average amortized time of O, 1, per operation. This makes dynamic arrays very efficient for adding elements. If an algorithm's complexity is O, n cubed, and the input size doubles, By what factor does the execution time approximately increase? Option A, 2 times. Option B, 4 times. Option C, 8 times. Option D, 16 times. The correct answer is C. For an O(n cubed) algorithm, if the input n becomes 2n, the new time is 2n cubed, which equals 8n cubed. This means that doubling the input size results in an 8-fold increase in execution time. This cubic growth is characteristic of algorithms with 3 nested loops and scales very poorly compared to linear or quadratic growth. What is the average case time complexity for searching an element in a hash table? Option A, O, 1. Option B, O, log n. Option C, oxygen mononitride. Option D, O, n log n. The correct answer is A. Hash tables are designed to provide near-instant access to data. In the average case, assuming a good hash function that distributes keys uniformly, searching for an element takes O(1) time. However, in the worst case, where all keys collide in the same bucket, it can degrade to O(n). But for complexity analysis and standard interview questions, the average case of O(1) is the defining characteristic of a hash table. Which sorting algorithm has a worst case time complexity of O(n squared, but an average case of O(n log n? Option A, merge sort. Option B, heap sort. Option C, quick sort. Option D, bubble sort. The correct answer is C. Quick sort uses a partitioning strategy. In the average case, it splits the array into 2 roughly equal halves, leading to O(n log n). However, if the pivot is consistently the smallest or largest element, e.g., sorting an already sorted array with a poor pivot choice, the partitions become highly unbalanced, size 1 and n1, leading to O(n squared). Merge sort and heap sort maintain O(n log n), even in the worst case. If an algorithm is theta, n log n, which of the following is also true? Option A, it is oxygen mononitride. Option B, it is omega n squared. Option C, it is O(n squared. Option D, it is omega n cubed. The correct answer is C. Big theta. Theta indicates a tight bound. If an algorithm is theta n log n, it grows exactly at the rate of n log n. Since n squared grows faster than n log n log n is contained within the upper bound of O(n squared). Therefore, if something is theta n log n, it is also O(n log n, O(n squared, O(n cubed, etc., and it is omega log n, omega n, etc. What is the time complexity of accessing the ith element in an array? Option A, O(1). Option B, O(i). Option C, oxygen mononitride. Option D, O log n. The correct answer is A. Arrays are stored in contiguous memory blocks. To access the ith element, the computer calculates the memory address using a simple formula: base address plus index asterisk size of element, single quote. Since this calculation takes the same amount of time regardless of the index or the size of the array, the time complexity is constant, or O(1). What is the time complexity of the standard recursive implementation of the Fibonacci sequence? F n equals F n1 plus F n2. Option A, oxygen mononitride. Option B, O n squared. Option C, O 2 caret n. Option D, O log n. The correct answer is C. The naive recursive Fibonacci function creates a recursion tree where each node branches into two more nodes. The depth of the tree is n, and the number of nodes roughly doubles at each level. This results in an exponential time complexity, specifically O 2 caret n, more accurately O 1.618 caret n. Using the golden ratio, this is highly inefficient compared to an iterative O(n) approach. What is the time complexity of binary search on a sorted array of size n? Option A, oxygen mononitride. Option B, O n log n. Option C, O log n. Option D, O 1. The correct answer is C. Binary search works by repeatedly dividing the search interval in half. If the value of the search key is less than the item in the middle of the interval is narrowed to the lower half. Otherwise, it is narrowed to the upper half. This halving process continues until the value is found or the interval is empty. The number of steps required is log 2 n, making the complexity O log n. What is the time complexity of the following code? For int I equals 0, I less than n, I plus plus. For int j equals 1, j less than n, j equals j asterisk 2. Print I, j. Option A, O n squared. Option B, O n log n. Option C, oxygen mononitride. Option D, O log n. The correct answer is B. The outer loop runs n times I from 0 to n1. For each iteration of the outer loop, the inner loop runs. However, the inner loop counter, j, doubles every time. 1, 2, 4, 8, as established in earlier questions. A doubling loop runs in O log n time. Since these are nested, we multiply the complexities n asterisk log n. Thus, the total complexity is O n log n. What is the time complexity of breadth first search? BFS. On a graph with V vertices and E edges using an adjacency list? Option A, O, V. Option B, O, E. Option C, O, V plus E. Option D, O, V asterisk E. The correct answer is C. In BFS, every vertex is visited exactly once. And for every vertex visited, we check all of its adjacent edges. In an adjacency list representation, the sum of the lengths of all adjacency lists is proportional to the number of edges. 2e for undirected, e for directed. Therefore, the total work is visiting all vertices, V, and checking all edges, E, leading to O, V plus E. What is the time complexity to insert a new node at the beginning of a singly linked list? Option A, O, 1. Option B, oxygen mononitride. Option C, O, log n. Option D, O, n squared. The correct answer is A. To insert at the beginning of a linked list, you create a new node. Set its next pointer to the current head. and then update the head pointer to the new node. These operations do not depend on the number of elements already in the list, unlike an array where you might have to shift elements. Linked list insertion at the head is a constant time operation. 1. Which of the following sorting algorithms is generally considered the fastest for small datasets, but has an O(n squared) worst case? Option A, merge sort. Option B, insertion sort. Option C, heap sort. Option D, radix sort. The correct answer is B. Insertion sort is very efficient for small datasets, typically n less than 10 to 20, and for datasets that are already nearly sorted. This is because it has a very low overhead compared to O(n log n) algorithms like merge sort. In fact, many high-level sorting libraries, like Java's dual pivot quicksort, switch to insertion sort once the subarray size becomes small enough. An algorithm has a time complexity of O(3n). Which category does this belong to? Option A, polynomial time. Option B, logarithmic time. Option C, exponential time. Option D, factorial time. The correct answer is C. Algorithms where the input size n appears in the exponent, like 2n, 3n, e(n), are classified as exponential time algorithms. These algorithms grow extremely fast and become impractical for even relatively small values of n. They are often associated with brute force solutions to nitrogen monophosphide hard problems, such as the traveling salesperson problem. What is the space complexity of an algorithm that creates a 2D matrix of size nxn to store intermediate results? Option A, oxygen mononitride. Option B, O(n squared). Option C, O(2n). Option D, O(1). The correct answer is B. Space complexity measures the total amount of memory space used by the algorithm relative to the input size. If an algorithm allocates a 2D array with n rows and n columns, it is using n*n equals n squared storage units. This is common in dynamic programming problems where a table matrix is used to store solutions to subproblems. In Big O notation, what happens to constant factors like 5n plus 100? Option A, they are kept for accuracy. Option B, they are dropped. Option C, they are squared. Option D, they are added to the exponent. The correct answer is B. In asymptotic analysis, we focus on the growth rate as n approaches infinity. Constant coefficients and lower-order terms become insignificant compared to the highest-order term. Therefore, 5n plus 100 is simplified to O(n). We drop the constant 5 and the constant 100 because the shape of the growth curve is determined by n. What is the time complexity of searching for an element in a binary search tree? BST. In the worst case? Option A, O log n. Option B, oxygen mononitride. Option C, O(1). Option D, O(n log n). The correct answer is B. In a balanced BST, the height is log n, so search is O log n. However, in the worst case, a BST can become skewed, essentially a linked list, if elements are inserted in sorted order. In a skewed tree, the height becomes n. and searching for an element requires visiting every node, leading to a time complexity of O(n). Using the Master Theorem, what is the complexity of T, n, equals 8T, n, 2, plus n squared? Option A, O, n squared. Option B, O, n squared log n. Option C, O, n cubed. Option D, O, n log n. The correct answer is C. Here A equals 8, B equals 2, and F, n, equals n squared. We calculate n caret log underscore BA equals n caret log underscore 28 equals n cubed. Now compare F, n, equals n squared with n cubed. Since F, n, is polynomially smaller than n cubed, specifically, n squared equals O, n caret 3 epsilon. For epsilon equals 1, we fall into case 1 of the Master Theorem. The complexity is determined by the recursive part, which is O, n caret log underscore BA equals O, n cubed. Which of these data structures has the best space efficiency for storing a sparse graph? Few edges. Option A, adjacency matrix. Option B, adjacency list. Option C, 2D array. Option D, all are the same. The correct answer is B. An adjacency matrix uses O(v squared) space regardless of the number of edges, which is wasteful for sparse graphs. An adjacency list, however, only stores the edges that actually exist, leading to a space complexity of O(v plus E). In a sparse graph where E is much smaller than v squared, the adjacency list is significantly more space efficient. What is the time complexity of checking if a string of length n is a palindrome? Option A, O, 1. Option B, O, log n. Option C, oxygen mononitride. Option D, O, n squared. The correct answer is C. To check if a string is a palindrome, you typically use 2 pointers, one at the start, one at the end, and move toward the middle, comparing characters. In the worst case, you examine half the characters in the string. N2 comparisons. Dropping the constant factor, the time complexity is O(n). What is the time complexity of building a heap from an array of n elements? Option A, O, n log n. Option B, oxygen mononitride. Option C, O, log n. Option D, O, n squared. The correct answer is B. While inserting n elements into a heap one by one takes O(n log n), the build heap algorithm, using the bottom-up approach with Heapify, takes O(n). This is because the work done at each level of the tree decreases as you move up from the leaves. The mathematical summation of the work at all levels converges to O(n). What is the best case time complexity of merge sort? Option A, oxygen mononitride. Option B, O, n log n. Option C, O, 1. Option D, O, log n. The correct answer is B. Merge sort is a divide and conquer algorithm that always divides the array into 2 halves and merges them back together, because it always performs the same number of divisions and the same amount of work merging, regardless of how the elements are ordered. Its best, average, and worst case time complexities are all O(n log n). A function calls itself 3 times with an input size of n1. What is the time complexity? Option A, 3n. Option B, n cubed. Option C, 3n. Option D, log 3n. The correct answer is C. The recurrence relation for this is T n equals 3t n1 plus 1. If you expand this recurrence, T n equals 3t n2 equals 3 squared t n2 equals 3 caret nt 0. This results in a complexity of 3 caret n. Each decrease of the input by 1 triples the amount of work to be done, leading to massive exponential growth. Which of the following functions grows the fastest as n increases? Option A, n. Option B, 2 caret n. Option C, n caret 100. Option D, 100 caret n. The correct answer is A. Factorial growth. N is faster than any exponential growth, like 2 caret n or 100 caret n, or polynomial growth, n caret 100. For example, while 100 caret n is huge, n will eventually surpass it because the base of the factorial, n, keeps growing, whereas the base of 100 caret n remains constant. In the hierarchy of complexity, n is near the very top of slow algorithms. That wraps up our 30-question deep dive into DSA complexity analysis. How many did you get right? Let me know your score in the comments. If you found this video helpful, hit that like button and subscribe for more deep dives into data structures and algorithms. It really helps the channel. For the complete practice exam and certification prep, check out the full course link in the description below.